total number of electric field lines passing normally through the surface is called as electric flux. What is delta phi? Delta phi is nothing but the electric flux, and in vector form we can represent it as vector E because electric field is a vector quantity into delta S. What is 2qa? It is nothing but dipole moment, and hence we get the expression E is equal to 2p divided by 4 pi epsilon naught into r cube. Hello everyone, welcome to session 4 of chapter 1 Electric Charges and Fields. This is Swati from Department of Physics, Vidhyaashram University College, the Temple of Excellence, Mysuru. Dear children, till last session we had discussed about the electric charges, electric fields, properties of electric fields, Coulomb's law and many more important topics. So in today's session, let us now start with electric flux. What is the meaning of electric flux? How is it different from electric dipole? So electric flux is nothing but the total number of electric field lines. Total number of electric field lines passing normally through the surface is called as electric flux. Suppose if this is a surface, what is the total number of electric field lines which are passing normally through this surface? That is termed as electric flux. So what is the expression for electric flux? It is given by delta phi is equal to E into delta S cos theta. What is delta phi? Delta phi is nothing but the electric flux, and in vector form we can represent it as vector E because electric field is a vector quantity into delta S. Again it is in vector form. Delta S is nothing but the surface element. So here we can say E is the electric field, delta S is the surface element, and what is theta? Here we have a term cos theta, that is nothing but the angle between the electric field and the surface element. So this is very important expression in finding answers and also in competitive examinations to remember delta phi is equal to E into delta S cos theta is the expression for electric flux. So now we got to know what is the expression of electric flux. So based on that we can say what are the factors on which the electric flux depends on. So it is dependent on the strength of electric field, that is delta E. It is also dependent on the area of surface element, that is given as delta S, because we have the expression delta phi is equal to E into delta S cos theta. So here it depends on electric field, the surface element, and also the angle between electric field and the surface element, that is E and delta S. So these are the factors on which the electric flux depends. So next we are moving on to an important topic, that is electric dipole. So the name dipole. So what is the meaning of dipole? It is nothing but a pair of two equal and opposite charges. Say for example I have minus q and plus q here, a pair of equal and opposite charges. They are separated by a distance of 2a. We'll call it as electric dipole. So from the center of dipole, if you consider the distance between P2 or the distance between the center of dipole to one charge is A and the distance between center of dipole to other charge is A. So on a whole, a pair of two equal and opposite charges are separated by a distance of 2A is called as electric dipole. So what is electric dipole moment then? So electric dipole moment, to remember the definition, we have an expression to remember, that is P is equal to Q into 2A. So we have electric dipole moment P is equal to Q into 2A. What is Q? Charge. What is 2A? The distance of separation between two charges. So it is denoted by P is equal to Q into 2A, which helps us in defining the dipole moment, that is the product of, you can see here, the product of either charge plus Q I have taken and the distance of separation between two charges of an electric dipole. So it is the product of either charge and the distance between two charges of an electric dipole is called as electric dipole moment. So in vector form we can write it as vector P is equal to Q into 2A P cap, where P cap is a unit vector and Q is charge and 2A is nothing but the distance between the charges. What is the SI unit of electric dipole moment? So you can see here we have the charge Q. So SI unit of Q is coulomb, and we have the distance between two charges, that is 2A, and the SI unit of distance is meter. So coulomb meter is the SI unit of dipole moment. So we have an important derivation from the chapter electric charges and fields, that is, what is the electric field or electric intensity at a point on the axial line of a dipole, or we can also say at a point on an axis of dipole. So I am telling on the axis of dipole, which means we must have dipole, correct? So what is a dipole? Equal and opposite charges separated by a distance of 2A. So I have a dipole here, look at this, plus Q and minus Q. These are the two charges separated by a distance of 2, and that is our dipole. So I have an electric dipole. Let us now have to find the electric field intensity at this point, which is on the same axis of dipole. So how to find it? We know what is the electric field expression. So we have to apply the same concept for the two charges plus Q. What is the electric field intensity due to plus Q charge? What is the electric field intensity due to minus Q charge? Now if it is 2A, from center of dipole, the distance between one charge and center of dipole is A, and the other charge to the center of dipole is A again. So now this is the point on the axis, and from this point the distance of separation to the center, from the center of dipole to this point, the distance is R. Now you can observe from plus Q to point it is R minus A, from minus Q to this point it is R plus A, because here up to here it is R. So from plus Q to this point till here it should be R minus A, and from minus Q to this point it is R plus A. So this is the diagram. Pictorial representation is very important, and this carries 1 mark examination point of view. So here you can observe P is the point on the axis of dipole, which is at a distance R, as I have explained just now, and from the center of dipole, the electric field at P we have to find out due to plus Q and minus Q. So first let us write the expression for electric field at point due to minus Q, that is E minus Q is equal to, as we know, it is 1 by 4 pi epsilon naught Q divided by the distance between this point and minus Q, that is R plus A, the whole square into P cap. Why I have taken negative sign here? Because it should be minus Q, that is due to the charge minus Q, and hence the expression E is equal to minus 1 by 4 pi epsilon naught Q divided by R plus A square into P cap. What is P cap here? It's a unit vector from minus Q to plus Q, which gives the direction. So let us now write the expression for electric field at P due to plus Q. So it is given by E is equal to 1 by 4 pi epsilon naught. Since it is plus Q, I have not taken any negative sign. Q divided by R plus A, the whole square into P cap. So now, according to the superposition principle, we know the electric field at any point is equal to the vector sum of all the electric fields due to the charges present in a system. So that should be E is equal to E plus Q plus E minus Q, which means the magnitude of electric field due to charge plus Q plus the magnitude of electric field due to the charge minus Q. So we have the expression for E plus Q and minus Q. Let us now substitute in the above expression. So what do we get? We get E is equal to 1 by 4 pi epsilon naught Q divided by R plus A the whole square, that is due to E plus Q, and 1 by 4 pi epsilon naught Q divided by R minus A the whole square into P cap, that is due to minus Q. Now from these two we can take Q divided by 4 pi epsilon naught common, and we remain with 1 divided by R minus A the whole square minus R plus A the whole square into P cap. Now in the denominator we have R minus A the whole square and R plus A the whole square. So taking LCM in the numerator we get R plus A the whole square minus R minus A the whole square. Just look at these two expressions. It is of the form A minus B into A plus B. So what is A minus B into A plus B? It is nothing but A square minus B square. So but we have A minus B the whole square into A plus B the whole square in the above expression. So we can write it as A square minus B square the whole square. And what do we get? E is equal to Q divided by 4 pi epsilon naught, and in the denominator we got R square minus A square the whole square according to this expression, and in the numerator look at this, we have A plus B the whole square minus A minus B the whole square. So expanding the term according to A plus B the whole square formula, that is A square plus B square plus 2AB, we get r square plus a square plus 2ra, and we have minus sign here. So I have taken minus sign, and we have here a minus b the whole square, which is a square plus b square minus 2ab. So according to that, I have expanded this. That's r square plus a square minus 2ar into p cap. So now this is minus r square plus r square will get cancelled, plus a square plus into minus will be minus a square will be get cancelled, and we remain with 2ra minus into minus will be plus 2ar. When we add that, we will get 4ar divided by r square minus a square the whole square into p cap. Now again, when the distance of separation between charges and the distance of point, that is r, we know the point is at a far distance on the axis of dipole, that is r, and r is very much greater than a. A is nothing but a distance between center of dipole to one charge. So r value is obviously greater than a. So in this case, a square term can be neglected, and we remain with E is equal to q divided by 4 pi epsilon naught 4ar divided by the r square the whole square. So now it is of the form r square the whole square. It is nothing but r to the power 4. But we have one r in the numerator, and we can cancel one r here, and we will get r cube in the denominator. So we can write this as 2 into 2qa divided by 4 pi epsilon naught into r cube. What is 2qa? It is nothing but dipole moment, and hence we get the expression E is equal to 2p divided by 4 pi epsilon naught into r cube. We know how did we get p? P is nothing but the dipole moment, that is product of magnitude of either charge and the distance between the charges, that is 2a. So we have 2qa here, which is nothing but a dipole moment. So we have replaced this with 2p divided by 4 pi epsilon naught into r cube. So the field due to a dipole varies inversely with the cube of its distance is the conclusion what we can give according to this expression. So this is electric field intensity at a point on the axis of dipole. So we have another important derivation which will be asked in exam for 5 mark repeatedly. Very important question, that is the electric field of an electric dipole at a point on the equatorial plane. So here at this point on the equatorial plane, we have to find the electric field intensity, and this is the equatorial plane derivation. So for this, diagram is very important. So I have considered a dipole here. You can see I have a plus q charge, minus q charge. They are separated by a distance 2a, which means it is an electric dipole. So now from plus q, you can see the electric field due to plus q is given by E plus q, and this field is resolved into two components along y-axis and along x-axis. So along y-axis it will be E plus q sin theta, and along this way it is E minus q sin theta, and going forward it will cancel out, and along the x component the components adds up. So here it is resolved again into E plus q cos theta and E minus q cos theta, and this is the distance of separation between two charges, that is 2a. Then from center of the dipole, a is the distance between plus q and center, a is the distance between minus q and center, and now the point P is located from center of dipole at a distance r, from the center of a dipole at a distance r in an equatorial plane. So when this is r and it is a, we have the side a to p, it is root of r square plus a square according to Pythagoras theorem. And when this is root of r square plus a square, the opposite side of which is also equal to root of r square plus a square. So this is how you have to note the diagram properly, and let us now derive the expression. So let us consider P. P is the point on the equatorial plane which is at a distance r from center of the dipole. This is a dipole. From its center, I have a point P which is at a distance r. So now we have to write the magnitude of electric field due to plus q charge and minus q charge. So the magnitude of electric field due to minus q is given by E minus q, which is equal to 1 by 4 pi epsilon naught. We already know how to write the expression for electric field intensity at a point. So based on that, I am writing E minus q is equal to 1 by 4 pi epsilon naught q divided by root of r square plus a square the whole square. Because we know the expression for electric field intensity is 1 by 4 pi epsilon naught q divided by r square. R is nothing but the distance of separation. Now, so from this charge I have taken to P, so the distance is root of r square plus a square. Since we have r square in our basic expression, it should be the whole square. So it is root of r square plus a square, the whole square. Now square and square root will get cancelled and we remain with e minus q is equal to 1 by 4 pi epsilon naught q divided by r square plus a square. That's our equation 1. So this is the electric field due to charge minus q. Similarly, we have to write the magnitude of electric field at P. P is the point where we are finding the electric field due to plus q. Now, what is the magnitude of electric field due to plus q? It is E plus q is equal to 1 by 4 pi epsilon naught. The charge is q itself and the distance between P and A, that is plus q, is given by root of r square plus a square. So, it will be root of r square plus a square, the whole square, and these two will get cancelled and we remain with E plus q is equal to 1 by 4 pi epsilon naught q divided by r square plus a square. That's our equation 2. So, from equation 1 and 2, we can say that the magnitude of electric field due to minus q and plus q are same. That is E plus q is equal to E minus q. As I already said, so the resultant of electric field at P can be obtained by resolving the components along x-axis and y-axis, and the components along y-axis will get cancelled. The components along x-axis will add up. So when adding the components along x-axis, we get electric field E is equal to E plus q plus E minus q, that is the magnitude of electric field due to plus q, the magnitude of electric field due to minus q into cos theta p cap. Because we have the components along x-axis, that is E due to plus q cos theta plus E minus q cos theta. So from this we can take E plus q plus E minus q common and we remain with cos theta. Since we are finding the electric field at a point P, which is a vector quantity, I have to represent this in unit vector. So it is with P cap. So we arrived at this expression. We can observe a negative sign here. Why is a negative sign? You can observe the diagrams. The dipole direction is always from minus q to plus q. But here the direction of resultant electric field, what we are taking, that is from plus q to minus q. So the opposite in direction, and hence we have to represent this with a negative sign. So now let us substitute electric field due to plus q, electric field due to minus q in this expression with the relevant terms. So what do we get? E is equal to minus 1 by 4 pi epsilon naught q divided by r square plus a square, that's from equation 1, plus 1 by 4 pi epsilon naught q divided by r square plus a square, that is from equation 2. And cos theta, you can just observe this triangle. So from this cos theta, what is cos theta? Cos theta is equal to adjacent divided by hypotenuse. So what is adjacent? If this is 2a, the whole thing, then it will be a. And this will also be a. So now consider this triangle. Adjacent is a and hypotenuse is root of r square plus a square. So now we got the value for cos theta, that is a divided by root of r square plus a square. So we have substituted the same and p cap. So E is equal to minus 1 by 4 pi epsilon naught q plus q is 2q divided by r square plus a square into a divided by root of r square plus a square into p cap. Because we know that cos theta is equal to a divided by root of r square plus a square, as I have solved already. So now let us simplify this. Then E is equal to minus, we get 2q into a, that is 2qa divided by 4 pi epsilon naught. Here I have r square plus a square, but I can write this root of r square plus a square as r square plus a square to the power 1 by 2. And I have r square plus a square here 1 and this is 1 by 2. 1 plus 1 by 2 gives us 3 by 2. So we can write E is equal to minus of 2qa divided by 4 pi epsilon naught r square plus a square to the power 3 by 2 into p cap. Now at large distances, you can observe here, we have a here and this is r. So at large distances, when the point P is at large distance from center of dipole, since a value is very lesser than the value of r, we can neglect the term a square and we have to retain the remaining terms, that is E is equal to minus 2qa divided by 4 pi epsilon naught. When a square is neglected from this term, we get r square to the power 3 by 2 and we can cancel 2 and 2 and we get the expression here as minus 2qa divided by 4 pi epsilon naught r cube into p cap. Now we know product of either charges and the distance between two charges, that is Q into 2A, is nothing but the dipole moment, and it is denoted by a term P. So let us replace this 2QA with the term P, and we get E is equal to 1 by 4 pi epsilon naught P divided by R cube. This is the expression for electric field at a point in an equatorial plane. So in today's session, we have learned two important derivations and a definition of electric flux, and these two derivations are very important examination point of view. So please practice these derivations every time and be thorough with these two. So in the next session, let us learn many more interesting concepts from the chapter Electric Charges and Fields. See you all in the next session. Keep learning, all of you. Thank you.